right, welcome. I'm going to try and help you solve these beautiful graph theory questions. See how we go. My mic is not the best, so hopefully you guys can hear me quite well. I will get a better mic eventually. All right, so you can see the question here. I'm going to go straight to solving the question, okay? So what we're going to do is, just make sure my pen is on. It is. Let's draw the information. There are three hikers. An, By, and Chris. Let's call it A, B, C. A, B, C. What a coincidence, right? I have a good friend, Marcus, did that on purpose. Art had walked the Inca Trail, Kilimanjaro, and the Snowman Trek. Now, they says there are four routes. So let's put IT, K, S, and there's an overland track, so O. Arnold has walked everything except for the overland. So let's just draw it. 1, 2, 3. By had walked the Inca Trail, Kilimanjaro, and the overland track. So that's 3. So Inca Trail, Kilimanjaro, and the overland. And Chris had walked the overland and the snowman. The overland and the snowman. See how I'm saying it as I'm drawing it just to make sure I don't make any silly mistakes. And that's your answer for the first one. Now, you're wondering, what does bipartite mean? It just means that one group must connect to another group. So this is one group, must always connect to another group. It just means I cannot have A cannot connect with B. That is not a bipartite graph. It must connect to another set, which is what we have. See, all my A trails are always connected to another set. There's no trail connected to B or C. Hope that makes sense. All right, that's the first question. Next question. You can see the question on there. List the vertices one to each. We're trying to find two sets. That's what they're asking us. So remember, same deal. What if I go? Okay, cool. I want to draw a circle here. Triangle. Circle. Triangle. Circle. Triangle. Circle. So done. Now what are my circles? U, Q, S. I'm sure there's a way to write this properly, but let me show you the two sets here. And then my circle ones are, oh, I can't actually see what I wrote in there. But I'm guessing it's going based on Q, R, S, T. I think that's a P. P, T, R. I don't want to clear it out. But I think that's a P. I know I kind of hit it. I can't erase it. I don't have to erase the whole thing. P, Q, R, S, T, U. There we go. Yep. I'm pretty confident that's the case. That's the answer for that one. Now, next question. Complete the bipartite graph. A complete bipartite graph has 6 vertices. Determine the smallest possible number of edges. All right. So, what's a complete bipartite graph? It just means that if I have these two, for example, triangle, triangle, circle, circle, the circle must always hit the two other triangles, every other set, every other element in that set. So there's two triangles, that circle must hit two triangles. This circle here must hit two triangles. And vice versa, right? I can't miss any, right? It hits every other element in the other set. I hope that makes sense. So we can actually draw these out, but it's actually a very easy way to do this. So here's an example of a 6 vertices one. I'm going to have 2 here and 4 there. And must hit all the triangles. Must hit all the triangles. You see that? That's one possible one, but I want the smallest one. So what I do is I know n plus n from one set plus n from another set must equal the amount of vertices. So I know I can get, we know the vertices are 6, so I can get 1 plus 5. I can get 2 plus 4. I can get 3 plus 3. Okay? I want the smallest number of edges. And you will find the relationship is if you multiply the two vertices of each group, you actually get the edges, right? So for this case, right, I have 2 and 4. I must have 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. There you go. I have 8 edges. So the relationship here is m times n equals e. So which one's going to give me the smallest e? 3 times 3 is 9, so nope. Well, 9 is okay. But 2 times 4 is 8, so far 8 is winning. 1 times 5 is 5. 5 is the smallest. It's smaller than 8 and it's smaller than 9. So therefore, the smallest number of edges is 5. Possible number of edges, it would be 5. Right? And I can actually show you this to you. Let me quickly erase all this. I can quickly show this to you. So I can have one group, remember that 1 times 5, 1 plus 5 vertices, 1, 2, this is with the triangles, 3, 4, 5. I should get 5 edges. 1, 2, 3, 4, 5. That is a complete bipartite graph because I'm connecting to every other element in the other set. Okay, so the answer is 5. I hope that makes sense. I hope you're enjoying the video so far. I'm going to be doing a lot of these questions. I might tackle this one tomorrow or some other time, but I've got a lot of these questions. So please enjoy it. Hopefully you understood it. See you guys later. Cheers.